Hello, this is Dr. Brown. I'm going to work a homework problem in chapter 9.1. It happens to be an inverse sine problem. It's a little bit tricky unless you remember a good bit about similar triangles. So the problem is over here, and by the way, this is not drawn to scale. There are two circles that touch one another. The first one has a radius of 8, and this next one has a radius of 40, and they're touching one another, and they are inscribed in this angle here, which we want to find. What I have done here is I have blown the diagram up so you can see it a little better, and then drew a line between the apex out to the center of the largest circle, and of course it goes through both circles. So now we have a triangle with a hypotenuse that I'm drawing here. And these are right triangles. And notice, since the radius of the circle is 40, we have this length is also 40. This length is 8. The radius of that circle is 8. And then, of course, this is 8. And then we're going to let x be the distance between the apex of the triangle here to the circumference of the smaller triangle. So now we have a hypotenuse. This is the hypotenuse of this larger triangle. And the hypotenuse is going to be x plus 8 plus 8 plus 40. Which is equal to x plus 56. And notice for the larger triangle, the opposite side is 40. And we actually have two similar triangles. And the one that's similar to the larger triangle, of course, is the one I'm marking out in red. And since there are similar triangles, the ratio of 40 to the hypotenuse, which is x plus 56, is equal to 8, which is the opposite side of the smaller triangle, to its hypotenuse, which is x plus 8. So now we can cross multiply and get a linear equation. If you cross multiply, we get 40x plus 320 equal 8x plus 8 times 56 is 448. Now we have a very simple linear equation to solve. Subtracting 8x from each side, we get 32x. Equals 448 minus 320 which is 128. And now you get x is equal to 128 over 32, and x is equal to 4. So now we see the hypotenuse of the larger triangle is going to be x plus 56, which will be 60. And now notice that the angle here is theta over 2. We're trying to find this bigger angle, but the way we have split it in two, this angle there is theta over 2. So now we can say that sine of theta over 2 is going to be opposite over hypotenuse, which is going to be 40 divided by 60. And so theta over 2 is going to be inverse sine of 40 over 60. Now to get this, you have to put it in your triangle, and in your calculator. You can't do it on the unit circle. So you put this in your calculator, and you get that theta over 2 is 41.81. And theta is just twice that, which would be 83.6 degrees. So to solve this, you had to remember properties of similar triangles so that you could solve a fairly simple linear equation to get the answer.